In this section, we are going to be looking at dividing polynomials. The first process we're going to look at for dividing polynomials, I'm hoping is somewhat familiar to you because this is covered in other math courses at QCC that you would have taken before you got to pre-calc here, or in another college or in high school. You would have seen this before. So long division of polynomials. So when we're dividing a polynomial by a polynomial, there's a list of steps here. I think rather than go through them in detail, let's jump into an example and then we can come back and look at this. But briefly, the first thing we're going to do is make sure that the terms, so here, arrange the terms of both the dividend and the divider in descending powers of the variable. So make sure your exponents start with the biggest and go down. Next, we're going to do a division, then a multiplication, a subtraction, and then bring down. D, M, S, B. One way to remember this, dumb monkeys suck bananas. They don't eat them, they just suck on them. So D, M, S, B. And then we're going to repeat. So as I said, rather than go through the specifics, I don't know that it'll make much sense and it will be kind of boring. Let's go into this example here. So we want to divide x squared plus 14x plus 45 by x plus 9. And if we look here, x squared, x to the first, no x, that's in order. X to the first, no x, that's in order. So we have x plus 9, that's a 9, x squared plus 14x plus 45. So there is our division problem set up. First, we divide. So what do we divide? We divide the first term and the first term. So we divide the first term of the dividend by the first term of the divisor, or this divided by this. So I'm going to show, some of you can do this right in your head and go right here to write the answer. I'm going to show the workout here just to make sure everybody can follow what I'm doing. So we divide x squared by x. So x squared divided by x is x. So that's our division, and we put the x up top there as part of our answer. Next, we multiply. So for the multiplication, we take this and we multiply everything in our divisor by this. So we're multiplying x and x plus 9. So x times x, so this gives us x squared plus 9x. Again, some of you, I'm sure, just do the multiplication in your head and write the answer down there. I want to make sure everybody can follow what I'm doing, so I'm going to write it all out. And now that x squared plus 9x, you would write it here. Which brings us to the next step, which is the subtraction. So we're going to subtract this, so all terms get their sign flipped. So this becomes negative, and this becomes negative. And now we do the subtraction. X squared minus x squared cancels. You should always have this cancellation of your first terms. If you don't, you didn't do your division right, so go back and check your division. 14x minus 9x is 5x. Now we bring down the next term, which is the plus 45. And we start the process all over again. So we divide first by first. So 5x divided by x is 5. I was jumping to my answer there. And positive 5, so we put the plus sign here because now this is a different term, so we're going to have a plus or minus sign in between each term. X plus 5. Now we do the multiplication. This times everything here. So we have 5 times x plus 9. 5 times x is 5x. 5 times 9 is 45. And we write that multiplication answer here. So division, multiplication, subtraction. So now for our subtraction, flip the signs. This becomes negative and this becomes negative. And now 5x minus 5x is 0, cancels. 45 minus 45 is 0. So we're done. There's nothing more to bring down. And here we have no remainder. So what does this mean? What this tells us is our original polynomial, x squared plus 14x plus 45, can be written as the factors x plus 9, x plus 5. So our divisor and our answer. When there's no remainder, there's no reason to write a plus 0 here. There's no remainder. These are our factors. Why is this useful and important to know how to do? Because as we know from solving quadratics, one method is to factor, and then each of these factors can be set equal to 0 in an equation and solve to give us the roots or the answers to our quadratic equation. We can also do this for equations of degrees higher than 2, and if we are able to find one of the roots and factor so we don't have any remainder, we will then have information factors that we could set equal to 0 to solve. Okay, next example here. When we look, we can see it's not written in the order that it needs to. So the first thing we're going to do is write it in the order of descending exponents. So I'm seeing an x cubed here is the biggest. So we have 2x cubed minus 3x squared minus 11x plus 7. So we didn't do any division here, but in order to start the division process, we did have to rewrite it. So now let's set up our division. We have x minus 3, and then 2x cubed minus 3x squared minus 11x plus 7. So I just rewrote our dividend down. So first step always is division. First term by first term. So we have 2x cubed divided by x, which gives us 2x squared. So I'm going to write my 2x squared here. And now for the multiplication, it's 2x squared times this whole divisor, x minus 3. So 2x squared times x is 2x cubed. 2x squared times negative 3. 2 times negative 3 is minus 6x squared. So let's write this here, 2x cubed minus 6x squared. So there's the multiplication. Next, subtraction. So we switch the signs. This was positive, we make it negative. This was negative, so I'm going to make it positive. Notice I circle my sign so that when I combine, I pick up the right version of it, and I don't pick up, in this case, the negative 6. It's positive 6. We're going to be combining. So 2x cubed minus 2x cubed cancels. Negative 3x squared plus 6x squared. That gives us positive 3x squared. And now we bring down this negative 11x, and we start the process all over again. For division, it's the first divided by the first. 3x squared divided by x is 3x, and it's positive, so I write my 3x there. And now the multiplication, 3x times this whole divisor, x minus 3. 3x times x is 3x squared. 3x times negative 3 is minus 9x. And I put that here, 3x squared minus 9x. And once again, we subtract. So this becomes negative, that becomes positive. 3x squared minus 3x squared cancels. As again, you should always have those first terms cancel. Negative 11x plus 9x is minus 2x. And now we bring down that plus 7. That's a poor looking 2x. And we start the process all over again. So division, first and first. Negative 2x divided by x is equal to negative 2. So I put my negative 2 up there in the answer. And then for the multiplication, we have negative 2 times this whole divisor. So x minus 3, negative 2 times x is negative 2x. Negative 2 times negative 3 is positive 6. And we put that here. Negative 2x plus 6. Now, if you're doing it in your head like this, you won't have this. You'll be writing your information right there. So, subtraction, we flip the signs. This negative becomes positive. This positive becomes negative. Negative 2x plus 2x cancels. 7 minus 6 is 1. So in this case, we have a remainder. So when we have a remainder, what that says is that we can't use x minus 3 and set it equal to 0 to help us solve this because this does not factor. We have a remainder. So what this says is our 2x cubed minus 3x squared minus 11x plus 7, that this is equal to x minus 3 times this, okay, so it's looking like we have factors, but we have a remainder here. So we have to put that plus 1. And so you can see, because on this side of the equation we have factor, factor, but then we have a plus for this remainder, we cannot use this information to solve, to find our roots or our solutions to this equation. So it's only when we have a remainder of 0 that we're able to use the factors here to solve for our roots. So this answer, this is kind of chock-a-block full here. So the answer here would be 2x squared plus 3x minus 2. And then this remainder of 1, we are going to write as 1, the remainder, and it's going to be a fraction with the denominator of the divisor. So this becomes the denominator if we have a remainder. Okay, so any remainder would go over this denominator here. So that is long division.